I'd like you to consider with me how amazing it is for mail, like a piece of mail, to be set up and sent and have it delivered to almost anywhere in the world. It's amazing. How's that done? Well, behind the scenes, there's a lot of infrastructure that makes it possible, but one key element of that is the address. We have addresses that we're familiar and common with when moving mail around. We also have in computer networks IP addressing, logical addressing that we assign to our computers and to our networks that also allows the forwarding of traffic to a given device on a given network. In this nugget, I would like to talk with you and demystify with you the concept and idea about IP addressing. So let's start off with a true story. I used to live in a community where my address included these numbers. Now, part of this information was the house number, part of that information was the street number, and it would be important to be able to delineate which was which. Is like, is this the house and this is the street, or is this the dividing line between the house and the street? It'd be important if we're going to deliver mail to that address to know where the dividing line is. Well, with an IP network, an IP is an acronym for Internet Protocol. IP is associated with layer 3 of the TCP/IP protocol suite. And IP addressing includes two major components. It includes the network, which we can think of like a street. And if we consider the concept of a street, everybody has to share the same street name. Like if I live on Elm Street, or you live on Jefferson Street, or you live on 42nd Street, that's the same street name that everybody else who lives on that street is also going to have as part of their mailing address. So we can think of a network address like a street name. And then on each street, we have individual houses. And in computer terms, we refer to those as hosts. Now, a host could be a computer, it could be a printer, it could be some other device that has an IP address. But that's the two main components in an IP address is the network information, like the street name, and the host information, which is like a house number. Now, in computer networks with IP, and I'll specify IP version 4, which has been around for a long, long time, and it's not going anywhere soon. IPv4 is made up of 4 numbers. And the syntax for those 4 numbers is A, B, C, D. Now, those are just placeholders. And the A, B, C, D represent the first number, and the second number, and the third number, and the fourth number. And they separate the numbers by periods. Now, each of those numbers can be a number between the range of 0 and 255. So if we had an IP address that looks something like this, 10, now if this looks familiar, that's because it is. We've been using this IP address on Computer 2 for the entire course so far. So 10.1.0.10. That's an example of an IPv4 address. It's got 4 numbers. Each of them is between 0 and 255, and there are 3 periods just to separate the 4 numbers from each other. Now, going back to this new information here, though, part of this information of this IP address represents the network, and part of this information regarding the IP address represents the individual host for Computer 2. And the big question is, where is the dividing line? Is it between the first 10 and the rest? Or is it 10.1 and the rest? Or is it 10.10 and the rest? Where is the dividing line? And it's a darn good question. And the dividing line is indicated by something called a mask. Sometimes it's referred to as the mask or subnet mask, but in either case, the mask is the dividing line. And a common way of saying the mask is with decimal numbers. So 255.255.255.0. And the bottom line of what this means is that the 255 means that the first number of the IP address is all network. The second grouping of 255 means the second number is all network. And the third grouping of 255 means that the third number of the IP address is all network. And this last 0 in the mask means that the corresponding number, the 10 in this case, of the IP address is not part of the network. And that means it's the host identifier or the host address for Computer 2. So we could say that Computer 2 is on the network of 10.1.0 and its actual house number or host address is .10 on that network. But if we looked at the computer, it would look like, oh, the IP address is 10.1.0.10 with this mask of 255.255.255.0. And what I think would be a great idea for us right now is let's use the online lab and go to Computer 2, and we'll run a command called ipconfig to verify that that's the IP address that it has on it. And we'll also take a look at this mask, which is the dividing line between the network portion on the left and the host portion on the right. So we'll give the hands-on lab a moment to initialize, and then we'll jump in on the client PC. So here on the client PC in the hands-on lab, we'll right-click on the Windows icon, and we'll go to a command prompt by selecting Command Prompt from the menu. And then here at the command prompt, we can type in ipconfig. Now earlier, we used ipconfig /all to see all the details, including the layer 2 address. But for right now, we can just run ipconfig all by itself, press enter, and that can give us a more simplified view, including its IP address, which is 10.1.0.10, the mask, which is 255.255.255.0, which effectively means that this is the network right here, the 10.1.0 network, and the host portion, or host address, if you will, for this specific computer is .10 on the 10.1.0 network. So in this nugget, we've identified that an IP version 4 address is 4 numbers long. The range of each of those numbers is 0 through 255. They're separated by 3 periods, and it's the mask that identifies which portion of that is the network and which portion is left over for the actual host or house address on that network. We've also identified how we can see an IP address and the mask on a computer, on a Windows computer, by using the command ipconfig without any additional options. So I'll see you in the next nugget. Until then, I hope this has been informative for you, and I'd like to thank you for viewing.